Let's begin by browsing to Wireless, Radio Settings, and then we'll select RF Profiles. By default, all indoor APs in your network are assigned to the indoor profile, and outdoor APs, they're assigned to the outdoor profile. We will create a custom RF profile by simply selecting New Profile. The dashboard provides us with a couple of templates to choose from. The 5 templates are explained within the dashboard here, and within our documentation shown here. Let's continue creating our custom RF profile by selecting New Profile from scratch. We'll start by creating a unique name for our RF profile, which will be the name we apply to our group of access points later. We will use corp-deploy. Under all SSIDs, we can specifically enable or disable the operation of the 2.4, 5, or 6 GHz RF bands. We can also select per SSID and customize the RF bands per SSID for even more granularity. We also have a feature for band steering to clear up some of that 2.4 GHz RF band and move those devices to the 5 GHz RF frequencies. One of the cool features we have is our flex radio selection. If any of our access points include a software-defined flex radio, we can configure it to operate on either the 5 GHz or the 6 GHz band here. However, 6 GHz is always subject to WPA3 or OWE for our wireless networks. We have the ability to also customize our minimum bitrate settings directly below the flex radio selection. Using a minimum bitrate per SSID may lead to holes in your wireless coverage if your access point deployment was not expertly planned. It is recommended to consult a wireless expert before using a minimum bitrate per SSID. But next, we can turn client balancing on or off. This feature attempts to balance clients across our access points. Let's take a look at the 2.4 GHz radio settings. The dashboard automatically selects the appropriate channel for 2.4 GHz access points, assigning between channels 1, 6, and 11. However, if we want to customize this, we could choose Change Channels Used by Auto Channel. By modifying this next slider below, we can optimize the radio transmit power range and alter our coverage area. After the transmit power setting, we have the AP radio receive power setting, or RX-SOP. A wireless expert should only modify these settings as they control your wireless cell size per access point. Customizing the minimum bitrate next allows us to omit legacy clients from our network and improve wireless throughput. For example, increasing the minimum bitrate from 11 to 12 removes legacy 802.11b support within this specific RF profile. We also have the option to disable 802.11ax, and we should do this if our legacy wireless client devices are experiencing compatibility issues when trying to connect to the network. Let's focus on the 5 GHz radio settings next. The initial settings are quite similar to the items we just covered, so let's go right to the 5 GHz channel width setting. We can let the dashboard handle it, or we can manually customize our channel width planning. By selecting Manual, we can assign the channel width we'd like our access points to utilize. With smaller channels, such as 20 MHz, we have 28 non-overlapping channels. That's recommended for our high-density deployments and our environments expected to encounter DFS events. Having more unique channels, that should really help us reduce the chance of wireless interference. When operating 40 MHz channels, we have 14 non-overlapping channels, recommended for low to medium density deployments. We can even offer 80 MHz channels, which is not commonly recommended yet. By operating only 7 non-overlapping channels, we may get higher bandwidth and data rates for our most modern devices, significantly increasing the risk of interference though. To customize our 40 MHz wide channel deployment, we can simply select Change Channels Used by Auto Channel. There's our beautiful graph of the channels available for selection. We can even use the Deselect DFS Channels feature which significantly limits our channel availability, but it does remove our interference-prone RF channels. We'll then select Done. We can scroll down to display the entirety of the 6 GHz band deployment. These are the same settings mainly as the 5 GHz, but as you can see, you can choose standard power service for AFC, channel width, channel assignment method, radio transmit power range, minimum bitrate, and more. The manual channel width options are similar to 5 GHz, but they also offer a higher than 160 MHz. Let's choose 40 MHz channels, and we'll select Save. The Corp Deploy RF profile appears within our listing. Let's get this RF profile applied to some access points. We will select the Overview tab, and select our appropriate access points. Next, we will select Edit Settings, followed by Assign Profile. We can choose the Corp Deploy profile, and select Next. We can clear any manually configured AP per radio settings that might have been previously applied to our access points. We'll select each checkbox to remove those previous AP customizations and select Review Changes. We can review the customizations and then select Apply Changes when ready. Behind the scenes, the dashboard sends the corresponding settings for our mapped RF profile to these assigned access points and their radios. We can verify that our radio settings page displays the updated RF profile mapping across the applicable wireless radios. And as a final step, we should always test our wireless client connectivity and optimize our RF profiles as needed.